All right, today we are going to talk about and work with the quadratic formula. Now, we're still working with quadratic functions. We're still solving quadratic functions. And last week we factored to solve functions, completed the square, set factors equal to 0. And when you get a quadratic function that you can't factor and you can't complete the square and you don't have any options left available to you, you have to use what's called the quadratic formula. And the quadratic formula is used to find the solutions of a quadratic function. The formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of it divided by 2 times a. And we're going to say here for a function in the form ax squared plus bx plus c equal to 0. The way that this quadratic formula works is you manipulate your function until it is in this form here, this ax squared plus bx plus c form, which basically means everything's on the left-hand side of the equal sign, and the equation is set equal to 0. Whatever sits in front of the x squared is your a value. Whatever sits in front of just the x is your b value. And the term that doesn't have an x or an x squared next to it, your constant term, is your c value. And then you take those values, you substitute them into this formula, and you have the solutions. So let's do a problem. Let's solve. We've got 2x squared minus x equal to 4. All right, so the first thing we want to do is we want to get this equation in standard form. So we're going to subtract the 4 from each side. So we get 2x squared minus x minus 4 is equal to 0. The next thing I would do is identify my a, b, and c. So in this case, our a is 2, our b is -1, and our c is -4. And then you take those values and you substitute them into the formula. So we're going to say that x is equal to the opposite of b. All right, b is -1, so this is 1 plus or minus the square root. Now we got b squared, so we've got -1 squared minus, we got 4 times a, which is 2, times c, which is -4. All of that is going to get divided by 2 times 2. So we're going to say that x is now equal to 1 plus or minus the square root of, let's see if we can just type all this in the calculator. Let's see what happens. We're supposed to get 33 underneath there. So let's go 1 negative x squared minus 4 times 2 times 4 negative, and hit equals. All right. If you just type this in the way, well, kind of the way you see it. All right. When you type negatives into this, I don't know, it depends on which calculator you're using. When I type negatives into my calculator, I have to type the number first and then the negative. But if I just typed all of that right there, left to right, straight in the calculator, I hit equals and I got a 33. So it saved me a bunch of time. Now look, this is over 4. All right. Those are your solutions. Now, you could see your answer in this form. All right, 1 plus or minus square root of 33 divided by 4. You could also see it finished, meaning as decimals. So if you did in your calculator, all right, if we go x equals 1 plus square root of 33 divided by 4. So 1 plus 33 square root equals, and divide that by 4. Get 1 point, second fix 2, get 1.69. So 1.69, there's one solution. And then we got to do x equals the 1. Now it's, since this is plus or minus up here, we do it 1 plus radical 33, then we got to do 1 minus radical 33. And we got to divide it by 4. So 1 minus 33 square root equals, divided by 4 equals negative 1.19. All right, so those are what are called your solutions. Those are the zeros of the function, which means those are the 2 points on the x-axis that this parabola will cross. Better way of saying that is it's where the parabola will touch the x-axis in those 2 places, 1.69 and negative 1.19. Good stuff, huh? Just a great way to start the old Monday morning. All right, so let's do one more of these, and then we're going to move on. We're going to solve now. We're going to solve, let's see, what do we got? X squared plus 4x minus 3 equal to 0. So now this problem, it's already in standard form, so you got no manipulation to do. You can just list your A, B, and C. So the A is equal to 1, B is equal to 4, your C is equal to negative 3. You take your formula and you substitute. So we got the opposite of B, so we got negative 4, plus or minus the square root of b squared. So we got 4 squared minus, what is the rest of that? Minus 4 times a times c. So we got 4 times a, which is 1, times c, which is -3. All of it is divided by 2a, so it's 2 times 1 this time. So our x is going to be equal to -4 plus or minus the square root of 4x squared minus 4 times 1 times 3 negative equals, I got a 28, all divided by 2 times 1, which is 2. So there's one form of your solutions. Another form, we'll just solve this twice. So if we say that x is equal to -4 plus radical 28 divided by 2, and -4 minus radical 28 divided by 2. So 4 negative plus 28 square root equals, and then divided by 2, 0.65. And then 4 negative minus 28 radical equals, divide that by 2, -4.65. All right, so there's your 2 solutions. All right, the second part of your lesson today, we're going to talk about the discriminant. The discriminant of a quadratic. In the form ax squared plus bx plus c is the value of b squared minus 4ac. This value is called the discriminant. So this was it. 28 was the discriminant of this first function we solved. 33 was the discriminant of that first function that we solved. Because everything that's under the radical, this right here, b squared minus your 4ac, that's your value under the radical. That value has a name. That name is called the discriminant. All right? So we're going to say here that when the discriminant, we're going to do a little table. Let's say value of discriminant. Then we're going to have number of solutions. and then the x-intercepts. All right, so when the value of the discriminant is greater than 0, value of the discriminant is greater than 0, any value greater than 0, you're going to have two real solutions. And you're going to have x-intercepts. You're going to have two of them, all right? So you're going to have a potential graph that you're going to have two x-intercepts, all right? You could have a graph that looks like this. All right, so here's your two x-intercepts. If the discriminant is greater than 0, you could also have a graph that looks like this. It could open down, still going to hit the x-axis in two places. So if you were asked to determine how many solutions there were or are for this equation, you identified the discriminant. Since the discriminant is greater than 0, all right, 28 is greater than 0. If you know that the b squared minus 4a is greater than 0, you know that you're going to have two real solutions. All right, you also know that you're going to have two x-intercepts. If your discriminant is equal to 0, your value under the radical sign is equal to 0, you're going to have one real solution. Your x-intercepts, you're going to have one x-intercept. And what those graphs may look like could look like any of these. All right, look, it goes down and the vertex is right on the x-axis. So there's your x-intercept. The graph could also open down. And your vertex is right on the x-axis. That's the only point of the graph that touches the x-axis. All right, so discriminant equal to 0, you have one real solution. Your graph is going to touch the x-axis at one place. If your discriminant is greater than 0, you're going to have two real solutions. And your graph will touch the x-axis in two places. The last value you can have for your discriminant is when it's less than 0. If your discriminant is less than 0, then we have no real solutions. No real solutions. X-intercepts, we don't have any. Some pictures that represent that. Could be a graph right here. There's a parabola. It never touches the x-axis. All right, it opens up. Its vertex is above the x-axis. It never touches it. You could also have one over here that goes down. All right, vertex is below the x-axis. All of the y values are in the negatives. The graph never touches the x-axis. No real solutions. All right, so if you're asked here's what you'll be asked today. Let me make sure the wording is the same. Find the discriminant. Discrim. I didn't spell that right. D-I-N-T. Find the discriminant and number of real solutions. And let's say we get x squared. X squared equals 6x plus 5. All right, remember, we got to get everything on the left-hand side of that equal sign first. So we're going to subtract 6x and we're going to subtract 5 from each side, right? And when we do that, can't we just move it to the other side and make it the opposite sign and save some writing? Does everybody see that? Right? Can't we rewrite this as x squared minus 6x minus 5 is equal to 0? Now, we need b squared minus 4ac. That's what we need. That's the discriminant. So our a is equal to 1, our b is equal to -6, and our c is equal to -5. So we're going to substitute. We got b squared, so we got -6 squared minus 4 times a is 1 times c is -5. Just type it in your calculator. -4 times 1 times 5 negative equals, anybody get a 56? All right, so I got a 56. My discriminant is greater than 0, so I have 2 real solutions. That's it. Let's try one more of those. Let's do 2x squared. 2x squared minus 3x plus 7 equal to 0. Same directions. All right. So our a is equal to 2, our b is equal to -3, and our c is equal to 7. Our b squared minus 4ac, so we got -3 squared minus 4 times a times c. So we're going to do a 3 negative x squared minus 4 times 2 times 7. Anybody get -47? All right, we get -47. That's less than 0. We got no real solutions. Any questions? Using the quadratic formula to solve equations, and then using the value of the discriminant to determine how many solutions there are to the function. All right, so your practice for today is going to be on page 245. Page 245, let's do, we'll go 11 through 16, and then 25 to 33. We're going same as we have been, in the basket, or we're going to email pick. Now, you guys at home, give me a few minutes here to upload that page. I forgot to do it this morning, to be honest with you. You guys that are in class, give me a minute here to scan this page so that I can upload it, so that I can put it on the wall so that you can see it. All right. I apologize for my lack of preparation. These Mondays are rough on us old men.